Good morning, students. We have learned about the emergence of software engineering, the early build and fix style, that is the exploratory style that has its own difficulties. Uh, you learned the software engineers at the time of early programming. They start writing program immediately after getting an informal understanding of the problem. Once completed, uh, they starts fixing the problem. Thus, this usually doesn't meet the user's expectations. So they were lost in failure. Even for a small toy program, large number of fixes are required. So those programs are most erroneous programs, and they doesn't meet the user's expectations, requirements. After a series of such project failure, the emphasis on software development through well defined, ordered set of activities. These activities are graphically represented and textually written as software lifecycle model or a software development lifecycle or software development process model. So, the graphical or textual representation of all the activities that are carried out throughout the development of a software is termed as software development lifecycle model, or it is also called the software development process model. Let's see a few basic concepts before going to the lifecycle models. Okay, see, all living things have a biological life cycle. You know that humans, all animals, etc. All living things have a biological life cycle. For example, a seed grows to a plant, then to a tree, and finally dies. Based on that biological life cycle, software life cycle has been defined to specify different stages over which a software evolves. So it starts from the request of a customer, isn't it? For a software life cycle, the life cycle of a software starts from a request of a customer. The customer feeling the need for a software to automate his work. But he is not at all aware of or he can specify all his requisites. He is just feeling the need of a software to automate his work. His work may be much harder, so he feels a need for a software to automate his work. This stage is called the inception stage. That is, the first stage in a software lifecycle model is a inception stage. That is, he knows, he feels the need for the software, but he doesn't know how to specify the requirements clearly. This is called the inception stage. So, starting from this stage, the software evolves the different stages or phases. We say that the software development process has different phases or stages. Once the development is completed and the software is delivered to the customers, from there it starts the series of other operations called maintenance. So the development process is there. The development process is a several phases of development. It itself is contains several phases, and once the software development is completed and delivered to the customers, from there it starts another series of operations that is called the maintenance process. So maintenance means continuously making change upon the request from the customers. So after starting use of that particular software, the customer needs a set of another process also, or he may need to change the software to his need. At that time, the maintenance process begins. That is, maintenance is making change upon the request from the customers after the delivery of the software. So, life cycle of a software represents a series of identifiable stages through which the software evolves during the lifetime. Here we use the term process and methodology interchangeably. They are similar in somewhat sense, but there is a vast difference between process and methodology. Process has a broader scope and it addresses all the activities taking place during the software development. This process represents all the stages or all the activities in a software development process. We say design process, testing process, etc. But methodology prescribes the set of steps for carrying out a specific life cycle activity. It just represents a set of specific steps for carrying out the life cycle activities. Process represents the whole activities of a software development process. Methodology prescribes only a specific set of activities that may be carried out on the life cycle process. It may also include some rationale or philosophical assumptions. Process is highly technical. It has a scientific basis, but methodology can have some philosophical assumptions also. So, why do we use a development process? The early computer programming techniques has its own failures because they did not depend upon any methodology. They did not have a specified process with some scientific basis. So the softwares result in utter failure. They doesn't meet the actual requirements of the customers. So this is the need for need to use a development process. The primary use is that it encourages development process in a systematic and disciplined manner. It encourages team effort and understandability. So many software development organizations realized that adhering to a suitable lifecycle model helps to produce good software. And also it helps to minimize the time and cost overruns. So these are all the need for adhering or need to use a development process. Unless it depends upon a methodology or a development process, the software would be a failure. And there is a need to document a development process. So any organization should have a proper development process. It should use a proper development process and it should have a documentation also. Why should we document a development process? It provides accurate definition of process models. Anything in a written way makes the process serious. So accurate definition of the process models so that it could be understood by everyone, because the software is always developed as a teamwork. It is not developed by an individual. So it should have an accurate definition of process models and it should be conveyed to all the team workers. And seriously following the process, it helps. The documentation process helps in seriously following the process. And it is easy to tailor. And the documentation process is needed to qualify the quality assurance standard. So for these reasons, any software organization should use a developmental process and should use documentation. They should document the development process. Now we are moving on to the waterfall model. It is a developmental model. We here learn many models. There are many more models that have so far been proposed, but we learn only a few important and commonly used models. Why should we use a model? A model is always said to be a good one only if it has a correct phase entry and phase exit criteria. Phase entry and phase exit criteria. So, a good life cycle model should define the entry and exit criteria for each phase. That means a phase can start only when the corresponding phase entry criteria are satisfied. So, there is some criteria for phase entry, and only after completing the certain phase, the other phase starts. So, only after exiting the one phase, the other phase begins upon some criteria. The phase can be considered to be complete only when the corresponding exit criteria are satisfied. For example, the phase exit criteria for the software requirement specification phase can be that software requirement specification SRS document. Software requirement specification, that is the SRS document, is ready and has been reviewed internally and has been reviewed and approved by the customer. Only when these criteria are satisfied, the next phase can start. Okay, so this waterfall model also satisfies the phase entry and phase exit criteria. So the classical waterfall model is the basis for all other models. So we are going to learn the waterfall model, but it is not at all used in practical sense. The waterfall model can be considered as a theoretical way of developing software. It is a theoretical way of developing software, but it is not used in the practical sense. Because all other life cycle models are in some way or other based on the classical waterfall model. So we need to understand the classical waterfall model. So coming on to the classical waterfall model, the model is divided into certain phases. You see in the figure, the model itself is divided into certain phases. The whole developmental process could be divided into certain phases, and one phase, only after exiting one phase, the other phase begins. So the phases of the classical waterfall model begins with the feasibility study. The first and foremost step or phase in the classical waterfall model is the feasibility study. Feasibility study means understanding or analyzing whether the software development would be technically and financially feasible. As we learned in our earlier classes, always the software development process is an expensive one. So before starting with the development process, it should be analyzed that whether it would be financially feasible, and the software needs to be used for many years. So it should be analyzed that whether that software would be technically feasible, whether it would be compatible with the common available hardware. So feasibility study is mainly concerned with understanding or analyzing whether the software could be financially feasible and technically feasible. And the feasibility study also helps in the development of an overall understanding of the problem. It helps to understand the problem, and it helps to formulate various possible strategies for solving the problem, for easy understanding of the problem, and it helps in formulating various possible strategies to solve that problem, and also it helps to evaluate the different solution strategies. So feasibility study is the first step in the developmental process because it analyzes whether the software development would be financially and technically feasible, and it helps in the overall understanding of the problem, and it helps in the formulation of various possible strategies for solving the problem, and it helps in the evaluation of the different solution strategies. And the next step is the requirements analysis and specification. Second stage in the software development process. Requirements analysis and specification itself could be divided into two steps: requirements gathering and analysis, and requirement specification. So requirements gathering, it forms an important step because a software is always developed for a customer, and we should know the actual requirements of the customer before beginning with the development process. So requirements gathering and analysis phase, in that a software analyst or system analyst meet the customer and try to know what are the actual requirements of that customer. He may meet the customer several times, or he may meet the representatives of the customer several times, and he gathers all the actual requirements specified by the customer, and he documents all these requirements. So first one is requirements gathering all the requirements of the customers and analyze the requirements, because as we said, in the inception stage, this is the inception stage. In the inception stage, the customer does not really, he might not be aware of how to specify the requirements. He just know how he is doing his work, but he could not specify his actual requirements for the development of a software. So there is a need to gather the requirements and analyze the requirements, and then a system analyst should specify all the requirements that he has analyzed and gathered and analyzed. So gathering all the requirements, analyzing all the requirements, and then specifying the requirements in the form of a SRS document, software requirement specification document. So this forms the basic document from which the entire software is developed. So this is considered as the first document, important document. SRS document, software requirement specifications document, forms the basis for all the other developmental process. Then the next step is the design process. Once the software SRS document is developed, the document should be implemented to a design structure. That is, the design phase forms the software architecture. We are forming a software architecture from the SRS document. So the goal of the design phase is to transform the requirements specified in the SRS document into a structure that is suitable for implementation in some programming language. So we are converting the SRS document into a software architecture form. Later, this architecture would be implemented in any programming language. So usually design phase is carried out either using the procedural design approach or using object-oriented design approach. Procedural design approach is a traditional one. In that, it consists of two important activities. The first one is a structured analysis of the requirement specification, and the second one is the structured design activity. Though it is an earlier one, this is also used nowadays. The other one is the object-oriented technique, object-oriented design approach. We know object-oriented design approach provides more provisions than the earlier ones. It uses the concept of object, That means we are first forming, we would first form the objects on the real-time items, and then form a relationship with the specified objects. So object-oriented design process is a new technique, and it has been widely used. Many software organizations prefer object-oriented design approach rather than other traditional procedural design approach. The next phase of the software development process is the coding and unit testing. You know what is coding? Writing the program, implementing the design architecture into any programming language. That is, the purpose of the coding and unit testing phase of the software development is to translate the software design into a source code. You know, so source code means a program. Transforming or translating the architecture, software architecture or design architecture into a programming language, that is the coding. The coding phase is also sometimes called as implementation phase, since the design is implemented into a workable solution in this phase. That is, the design is completely translated into a programming language. So this is also known as the implementation phase. Once the coding is complete, every modules are unit tested. As the modules are developed individually, separately, each modules need to be tested. So testing on modules is called unit testing. So unit testing is performed on individual modules. Once a module is developed, each module would be unit tested. Unit testing involves testing each module in isolation from other modules and then debugging and documenting it. So the main objective of unit testing is to determine the correct working of the individual modules. So each module is tested in isolation, that means separately, as this is the most efficient way to debug the errors identified at this stage. And also it should be unit tested because other modules needs to interface with the other modules to which it interface may not be developed. So as each modules are developed individually, the modules need to be tested individually. So testing on individual modules is called unit testing. Next one is the integration and system testing. Integration means, as we said, different modules are developed individually, and these modules need to be integrated for a complete software. So integration of different modules is undertaken once they have been coded and unit tested. The integration phase is carried out incrementally over a number of steps. Not all the modules are integrated altogether in a single step. These integration of various modules are normally carried out incrementally over a number of steps. And during each integration step, previously planned modules are added to the partially integrated system. So we form a partial integrated system and the resultant system is tested. That is called the integration testing. Testing that is carried out on the partially integrated system is called integration testing. Finally, after all the modules have been successfully integrated and tested, system testing is carried out. That is, system testing is carried out on a fully developed software. System testing also consists of three different kinds of testing activities. That is alpha testing. It is the system testing performed by the development team. Once all the software development process is completed, that means in the step once all the modules are integrated, the system testing is performed by the development team. That is the first testing process. And then beta testing process, it is the system testing performed by a friendly set of customers. So after integrating all the modules, the developed software would be tested by the development team, the first testing process, and then it is tested by a friendly set of customers, the second testing process, and acceptance testing. This is the system testing performed by the customer himself after the product delivery to determine whether he should accept the delivered product or to reject it. So this acceptance test is the testing process that is done by the customer to determine whether he should accept or reject the software. That means he is testing whether the software meets all his requirements. System testing is carried out with a plant in a plant manner according to a system test plan document. There is it itself is also documented. System test plan. The system test plan document actually contains all the test cases with which the testing process should be carried out. That means it lists all the test cases and the expected outputs from each test case. And also it after carrying out the testing process, the result of the integration and system testing are documented in the form of a test report. So the test cases are also documented and the test report is also documented. And with this stage, the software is completely developed. Once developed, the completely developed software would be delivered to the customer. And from there, the other process begins, the series of process, that is maintenance. Maintenance requires much more effort than the effort necessary to develop the product itself. There is a ratio that states that if the development process is 40, the maintenance process should need 60. That means the effort of developing a software is lesser comparing with the effort needed for the maintenance. Once the customer starts using the software, he know there must be some maintenance needed on the software. So the maintenance involves performing any one of the following activities, that is corrective maintenance. Maintenance process involves three types of maintenance. First one is the corrective maintenance. It involves correcting errors that were not discovered during the product development phase. So corrective maintenance is for correcting the errors that may not be discovered during the development process. Second one is the perfective maintenance. Perfective maintenance involves improving the implementation of the system. To improve the implementation, or it is done for future enhancement, enhancing the functionalities of the system. And it is also done according to the customer's requirements. The third one is the adaptive maintenance. It is usually required for porting the software to work in a new environment to increase the compatibility of the software, or it makes adaptive maintenance is done to make the software work on a different environment, different platform. So this is the classical waterfall model. As we said, classical waterfall model forms a theoretical basis for all other models, so we have to learn the classical waterfall model, but it is not used in the practical sense. Why it should not be used in the practical sense? Because it has several shortcomings, several disadvantages. What are the shortcomings? There is no feedback path. The name itself says that it resembles a waterfall. That means it just if one phase is complete, it move on to the next phase. There is no chance for feedback path. That means no other phase could be repeated, and it is difficult to accommodate change request in that situation. If one phase is not cannot be repeated, there is no chance to accommodate change request from the customers. So customers could only specify the requirements at the first stage, at the requirements the second stage at the requirement specification gathering. And then there is no chance to accommodate any other change request. And this waterfall model is inefficient in error corrections. And there is no overlapping of phases. As we said, once a phase is exited, it is exited. There is no chance for a feedback. There is no chance of repeating. So these are all the shortcomings of the classical waterfall model. Hope you understand well. Thank you.